Today we'll be working on lesson 2-4 solving absolute value inequalities, and this video is going to be for my GT kids. In this video I'm going to be focusing on solving absolute value inequalities by dividing the absolute value into a left equation and a right equation like we did before, like we did in solving absolute value equations, like we did in graphing absolute value functions. So if you'd like to watch the video on how to do the less than and the greater like we did in some of the classes, please go ahead and watch the core video. This video will be focusing on dividing into a left and a right equation. Now that method is also good, but this builds on what we've been doing in class. Okay, so in this video I'm going to be doing number 1, 2, 5, and 7. Let's start on number 1, and this is going to be the practice sheet. So as you can see in number 1, you're asked to be solving the following inequality. An absolute value of x minus 18 is less than or equal to 5. Now, so this is, you have to say inequality. Now remember, just like an equation, your first step always is to what? So step number 1 is always to isolate the absolute value. And the second step is to change the absolute value into a left equation and a right equation like we used to do. Like basically rewrite it as a piecewise function. So let's go on to number 1 and see how we can do that. As you can see, the absolute value is isolated. So I'm going to start by rewriting the absolute value as a positive equation. And I'm going to copy everything else. And a left equation and copy everything else. So let's start solving each one separately. So as you can see, the right equation is x minus 18 and the left equation is going to be negative x minus 18. So let's start. You add 18 to both sides. So x is going to be less than or equal to 23. That's going to be your first one. And the second one, you can either distribute the negative, okay, or you can from the beginning divide everything by negative, and you're going to get x minus 18 to be greater than or equal to negative 5. You can do that right from the start. Add 18 to both sides. And then x would be greater or equal to 13. So that's going to be your second one. Now remember, every time we have an inequality like that, or two inequalities, we have, let's say, 0s over here, 13 over here, and 23 over here. Now x can be less than or equal, so solid circle, filled circle, going on to the left. And then the other one's going to be x greater than or equal to 13 and going on to the right. Now in problems like that, since we have, as you can see, an overlapping of some of the values, then you have to erase whatever you have. So let me delete this. Okay, so basically you have 0, 13, because I couldn't get to the eraser, I'm going to draw this again. So greater than 13 or less than 23 or equal to 23, you get to the eraser and you erase everything that is not overlapping. So it only overlaps between 13 and 23, and that would be your solution. So it means anything between 13 and 23 could be a solution to this inequality. Let's double check that. Let's take, for example, 20. Plug in 20. Always check. Remember, so step number 3 is always to check. Is this true? 20 minus 18 is 2. Absolute value of 2 is 2, and that is less or equal to 5. So yes, it is true, and my solution is true. Now to double check that, and I want you to have a better understanding of what that means. So let's go to y1. And I want you to put absolute value of x minus 18 in y1 and 5 in y2, okay? So in y1, we're going to go to second catalog, press enter to get to the absolute value. I'm going to put x minus 18 inside the absolute. So that's going to be a V shape, and on y2, I'm going to put 5. And that's going to be our straight line, a horizontal line, and let's graph it. You see that? Now, as you can see, my V shape is over here, somewhere over here, and I can't get to it. So let's try to see if I can drag the screen. No, I can't do that. Now, I thought the software would allow me to do that. So remember, on your calculator, you have to fix your window. It means you have to go to your X maximum. And I need to see the whole thing because this is the right side of your window. So let me put it to 20 and see what would that do. And the Y maximum, which means the top of your window, I'm going to put this to 30. And let's see what's going to happen. Am I going to be able? Yes, there you go. There you go, but still, I can see the top clearly, but I have to move it a little bit more to the right. So I'm going to go to the X maximum and put 40. Hopefully I can see the whole picture. And let me graph. Much better. I can see now the whole V. And that's your line. Okay, let me try to zoom in a little bit. Okay. It wasn't a good choice, so I'm going to put 3 and zoom out. And go back to how I was. Okay. So as you can see, the V shape is your absolute value and 5 is the red line. Okay. Now you want your absolute value to be less than or equal to 5. It means you are only interested in the part of the V that is below your red line. So less than means below. As you can see, this part is below your red line, so you're only interested in this one. So as you can see, this is going to be one inequality, a compound inequality. So instead of writing x less than or equal to 23 and x greater than or equal to 13, you can write this as one compound inequality, okay? And you can say that x is between 13 and 23, and you can see that the part of the V that is below your red line is between 13 and 23, so this is one part. So that's why you should have one compound inequality and one line showing that your solution is only going to be this small part between 13 and 23. So this is how you can better see it on the calculator. So let's go. So remember, every time you have, after you isolate your absolute value and you have a less than, think of it as one part, one compound inequality, one line. So you need where the two lines overlap. And in this case, it's between 13 and 23. Now let's move on to another example, which is number 3, which is very similar to what we just did. So I want you to pause the video and try this on your own and play the video again to see if you got it right. Now I hope you tried on your own. I'm going to do this now in front of you. Now remember, for me, I like my variable to be on the left side of my inequality equation, so I'm going to rewrite this. The absolute value of y plus 5 is less than or equal to 8. Okay, I'm going to rewrite this as a positive, or which is my right equation, and a left equation. Okay? And then what I'm going to do is I'm going to solve for my y. So y is less than or equal to 3. Now over here, I'm going to divide by negative, or you can just distribute the negative and divide later on. So I'm going to end up with y plus 5 is greater than or equal to negative 8. Subtract 5 from both sides. So y is greater than or equal to negative 13. Now again, I'm going to graph those. So let's say this is negative 13, and why did I do that? So let me put 0 a little bit in the middle. So you want y to be less than or equal to 3, and y is greater than or equal to y13, greater or equal to negative 13. So again, since they overlap, you're only interested in the part where they overlap. So then your solution is going to be between those two. Okay? Now again, you can graph it on the calculator and see that once you graph them, the part that is below the line is going to be the small V shape, and that's going to be between two numbers. So graph it to better see it. So I expect to see at the end a compound inequality showing me that y is less than or equal to 3 and y to be greater than or equal to negative 13. So that is a better representation of your solution, a compound inequality. Okay, now let's move on to number 2. Now again, no matter what, you do the same thing always. Step 1, isolate your absolute value. I'm going to rewrite this in a way I have my absolute to be on the left side of my greater, on the left side of my inequality. And as before, it doesn't matter whether you have a less than or greater than. What matters is that you always rewrite the absolute as a piecewise function, and you go from there to see what's going to happen. So I'm going to rewrite this as n right equation and a left equation. As you can see, there's nothing different. You copy everything else. So you isolate the absolute, you rewrite the absolute value as a negative and a positive portion, which is a left and a right equation, and you take it from there. So subtract 12 from both sides, so x is going to be greater than or equal to negative 3. Okay, divide by negative, so x plus 12 is greater than 9, negative 9. You subtract 12 from both sides, so you get that x is greater than negative 21. Okay, now I made a mistake, as you can see. When I divided by a negative, what should happen? You should switch the inequality. So when you divide by a negative, so your final answer is going to be x less than or equal to negative 21. Now let's graph this. The 0 is going to be over here, negative 3 over here, and negative 21 over here. So x is greater than negative 3, not greater than or equal. So you have to follow the inequality that you have there right from the beginning, okay? So x should be greater than negative 3, and x is less than negative 21. As you can see, here we do not have overlapping lines, so this is an OR relation. It means that your x can either be less than negative 21 or greater than negative 3. It cannot be between them, so this is more like an OR solution, okay? It means x can be in two different places, and if you check, or let's double check. So let me take a number that, for example, negative 30, and plug it in. Negative 30 plus 12 is negative 18. Absolute value of negative 18 is 18, and yes, 18 is greater than 9. Now go ahead, check 0, because 0 is greater than negative 3, plug it in. 0 plus 12 is 12, absolute value of 12 is 12, which is greater than 9, so it also worked. So your solution in this case is going to be two different inequalities, and it's an OR solution. It means x can be either greater than negative 3 or x can be less than negative 21. Now in order to better understand this, let's plug it in our calculator. I'm going to clear this and clear this. And remember, we did fix our window, so you might need to reset your calculator. Okay, so I'm going to go to y1. I'm going to put absolute value of x plus 12. So you always put, after you isolate your absolute value, that's what's going to go into your calculator. So I'm going to go to second, 0, enter, x plus 12. So as you can see, if it's less than or greater than, it doesn't matter. You isolate the absolute, you divide it into the left equation and right equation, you solve each one separately, you graph the points on the number line. If there's an overlapping situation, then that's a compound inequality, and your solution is going to be between two numbers. Hi Amanda. And if you see that you have two different inequalities, then you will have an OR situation, and then you will get two different inequalities. So let's try to graph those two. So as you can see, I was not able to see all of the V shapes, so I'm going to fix my window. I'm going to go to my x minimum, I'm going to put negative 40 to be able to see the left side of my graph. So that is my graph, and that's the line. Now, you're interested in the part where the absolute value, or the V shape, is above 9, greater than 9. So what part of the V shape is above 9? this is above 9 and this part is above 9. So how many parts do you have? Two different parts, and that's why you have two different inequalities, two different lines. Make sense now? You see how it's going from negative 21 to negative infinity? There you go. From negative 21 to negative infinity. And the other one is from negative 3 to plus infinity. There you go. This is negative 3 to plus infinity. So it makes more sense now. Now, please pause the video and try working on number 6 on your own. And I'll have the answer key online. Please check with the answer key. Now I'm going to be doing number 7. It's the same concept even if you have variables on both sides of the equation. So let's try working on that. You have to add 2x to both sides. Remember, you always try to isolate your absolute value no matter what. Now, after you do that, you have to divide by 3. So you get absolute value of 2x plus 2 to be greater than or equal to x plus 1. There you go. You isolated your absolute value. Now, after you do that, you rewrite this as a left equation. So nothing changes. You do the exact same steps. And a right equation. Now divide everything by negative. So the inequality is going to shift and the other side is going to change to a negative x minus 1. Now remember, again, you have to solve for x, so subtract 2 from both sides. And then you need to divide by 2. Subtract 2 from both sides, and then you have to move the x to the other side. So you get 3x to be less than or equal to negative 3. Now you need to find x. So x is less than or equal to negative 1. That's going to be your first solution. Now let's do the other for the other part of your inequality, and let's solve for x. And then move x to the other side by subtracting it. So you get x to be greater than or equal to negative 1. So we have two different solutions, x greater than or equal to negative 1 and x smaller or less than or equal to negative 1. So let's try to graph this on the number line. I might need to make some space, so let me erase. Okay, so both of them, so I have one to be less than or equal to negative 1 and another to be greater than or equal to negative 1. So as you can see, my solution seems to be the whole line, the whole number line, so it's an infinite solution. Now to better see this on the calculator, let's always go to the part where you isolated the absolute value. Okay, so that's the part. Graph the first one in y1, so it's going to be 2x plus 2. Now let's move on to the other side. It's going to be x plus 1. And again, since it's greater than or equal, you're interested in the part of the v that's above your x plus 1. So that's my v. There you go. As you can see, this line is going through the vertex, and you're interested in the part of the v that's above the line. As you can see, the whole v is above the line. So your solution is going to be the whole thing, and that's why it's infinite solution. It's all of it. So you can say you have an infinite solution, or you can say x belongs to R. It means it can be any real number. So this is number 7. Okay, now let's move on to number 4. Now again, when you want to solve something like this, you isolate the absolute. Absolute value of 3a minus 2 is going to be less than negative 3. Now before you move on and divide into a left and a right equation, take a minute and look at this. Can an absolute value be less than negative 3? Is this possible? Can a distance be less than a negative number? Never. So that is what? No solution. But I made a mistake over here, because when you divide by a negative 2, what happens? The inequality shifts. So that's absolute value of 3a minus 2 is greater than negative 3. So it's not less than anymore. Now, so you have to think about it again. Take a minute and think about it. Can an absolute value be greater than a negative 3? Can distance be greater than a negative number? Yes, this is always true. So what would be your solution? R. So your solution is going to be all of the number line. Now to better see this, let's go to our calculator. Always plug in the part that you isolated. It's easier to see, okay? It's not that if you plug in the main one, it's not going to work. It will work, but this is easier to see, okay? So I'm going to clear this and put -3, and I'm going to graph it. So that's my V, and that's -3. You see that? Now you're interested in the part of the V that's above -3. And as you can see, the whole V shape, the whole absolute value is above -3. So the same as before. Your solution is going to be infinite solution because all of the absolute value is above the -3. A distance can always be greater than a negative number. So your solution is infinite solution as well. Now let's move on to number 5. And again, you have to isolate your absolute value, so subtract h from both sides. You get absolute value of 4b plus 1 to be less than a negative number, and that is never true. So always take a minute once you solve before you start dividing into a left equation or right equation. When can an absolute value be less than a negative number? Never. So in this case, you have no solution. Now also to better see this, let's go to our y equals and graph it and see what part of my v is going to be below -8. So put 4x plus 1 plus 1, and you're going to put -8 on the bottom. Now let's graph it. And let's see what part of my v is going to be below -8. Now, there you go. That's the line. Can you tell me what part of your v, what part of your absolute value is below the red line? Nothing. So that's why there's no solution. So you can either think of it algebraically or you can think of it in terms of graphing it, okay? So it's up to you, and I hope that you understand the lesson. If you would like to check the answer key for the rest of the problems, please check our website and the answer key will be there. And if you'd like to see a different method of solving absolute value inequalities, please watch the core video where I talk about the greater and then. But if you get this method, great, you can use it. It builds on what we did in graphing and what we did in absolute value equations. I hope you have a wonderful day. I'll see you in class.